When I get here to school, at 10 after 5, usually most mornings, that's when I start anything from the day before that was put in the grade book. Yeah.
Oh, can we see the test today, or are there
Still people in it.
Oh my goodness.
I'm telling you.
like,
No, I'm not a big fan of that. Oh, someone's throwing rocks at it. Hey, what was the homework last night? I forget.
Nothing.
3.2B. Don't lie to me because I'll find out. 3.2B. 3.2B. All right. So, as far as 3.2B goes, get it out. Because was this one of those I said, get 3.1 and 3.2 and we'll put them together?
Yeah.
Okay. Do me a favor, have 3.2 on top when I come by, because I know you already did 3.1.
It's 3.2A.
3. But it's 3.2B that we did.
So,
So 3.2B. Anybody have questions on 3.2B on the front page? Front page only, yeah.
it was that one where it was like that one, 3B.
3B, okay. Let's take a look at 3B. I gotta go to the end of this. 3B. All right. So, how can we go through this one? A few things that you might keep in mind. So we know that these are parallel lines. I just extended them. So how can we go through? I have a transversal. So I guess with this would be simple that we know that 2x plus 90 equals 180. So 2x equals 90. So x is equal to 45. Okay, so that works there. That took care of that.
Oh, I get it.
And then I guess I could use this as our transversal here. So we know that this angle and this angle have to add up to 180. Plus 6y equals 180. Right? Wouldn't that? Those are they have to be supplementary. So then you get y is equal to 20. And did it just ask for x and y? Yeah. That all right? Anything else from the front side? 3C? Sure. 3C. All right. So we have this. And it's going to be parallel to this. So, let's see what we know. We know that these lines are parallel to each other. And if this is a transversal, so this here would have to be 65 degrees as well because those would be alternate interior angles. Yes? Would that be right? Okay. Which then we could take that a little bit further. I know that those three angles form a straight line. So 55 and 65 add together to give me 120. 120 from 180, that would be 60 degrees. Is that okay so far? Yeah. And if that's 60, this is a vertical angle to this, so that's 60 degrees. And this is a vertical angle to that, so that's 65 degrees. Is that all right? Huh. Anything else on either side? Yep.
On the back.
Uh-huh.
4A.
4A, okay. 4A. So this is parallel to this, which is parallel to this. And then this comes in like that. They tell us that this is 2x minus y. Tell us 2x plus y. Squeeze in there. This is 60. This is 40. Is that right? Okay, so these have to add up to 180. These have to add up to 180. So I have 2x minus y equals, or plus 60 equals 180. So this has to equal 120. Is that okay how I just did that for this top? Everyone, you follow that okay? And then I have 2x plus y plus 40 equals 180. So 2x plus y plus 40, so I'll subtract the 40 from 180. That becomes 160. So that's the same as that. And I'm just trying to shortcut it a little bit. So let me know if you don't have a understanding of what I'm doing. And at this point, I can add these two equations together. It gives me 4x. The y's are gone, equals 280. So x equals 70. Would that be right? Yeah.
Wouldn't it be 2x plus y equals 140? Because you're subtracting 40.
If this is 140?
Yeah.
260. Is that 260 then? Did I do that wrong? 180. 140. Yeah, that's 260 then if I add it. So 4 goes into 260 how many times? Uh-oh. See, 4 goes into 26. How many?
Oh wait, no, 20.
How much? 65? Okay. So if x is 65, we know that's 60. So that means that, right, 2 times x is 130. 130 minus y. We'll be able to solve that in a sec. And then 130 plus y. Okay, so again, if I know this plus this, so that's going to be 190 minus y equals 180. And I subtract that, I get that. So y is equal to positive 10. We're done. We don't have to solve both then. So y equals 10, x equals 65. Yeah. 4D. Okay. 4D. These are parallel. Transversal. X plus 10y plus 10. 8x minus 2. 6y plus 2. All right. I know that this has to be 8x minus 2 as well. Because of vertical angles to this, and the reason I'm doing that, I guess we could say alternate exterior angles would work as well. Let's see. I know that these two angles here, or these two angles here, have to add up to 180. So let me write that out. I'm going to forget a few things. Plus 10 plus 8x minus 2 equals 180. And then I could use alternate exterior angles. So those two are equal to each other. So that would be here and here. Alternate exterior, or being I put it here, I could do corresponding, doesn't matter. They're still going to be equal. To get that. So now I have that green equation and the black equation, so let's just do them in blue. So let's take this one and just clean it up a little bit. Looks like 9x plus 10y. That's 8, so that's going to be what? If that's going to be positive 8, that's 172, is that right? Did I do that right? Okay. And I'm going to bring that over, so I have 4 over here. And then I'm going to bring 8x minus 6y. I just modified this a little bit. Is that okay? I think the y's would be the better to get rid of. So I could say that the smallest number that 10 and 6 have in common would be 30. Is that right if I said that?
Yeah.
Okay, and if you have a calculator, I need your help, please. So if I'm going to make this 30, I'm going to multiply this by 3 and this by 5. So this comes out to 27x plus 30y. And what's 172 times 3?
Oh, frick.
I don't know. That's why I said if you have a calculator. How much?
452.
Do we have somebody with a calculator that's actually doing this?
No.
Or are you just yelling out arbitrary values? It's 5? Good.
No, it's 5. No, wait, what am I doing?
How much?
Hold on.
Holding on. I'll do the other one down here real quick. That's 40x minus 30 equals 30y equals 20. How much is it?
It's 516.
516. So 3 times 172 is 516. 516. Cool. All right. So now we can add these together. Keep the calculators out if you have it. I get 67x. Those cancel equals 536. 536 divided by
Oh my god.
536 divided by 67 is 3. 8. Thank you. X is equal to 8. So if my x value is 8, so that would be 64. This would be then 62-degree angle. And so I know that those two have to add up to 180. So I know x is 8. 8 plus 10y plus 10 plus 62 equals 180. And yes, I did it probably a longer way than you would have, but deal with it. 70, 80, y is equal to 10 if I solve that. I think those are my answers. So it's not getting a little algebra on you on that one. What do you think? I do all right? Any other questions? Yeah. 4C. 10x, 4x plus y plus 25, and 6y plus 10. So I know that 4x plus y plus 25 is plus 6y plus 10 equals 180. Let's clean this up a little bit. 7y, 4x plus 7y. That's 25, 35. 180 minus 35 is 145, thank you. So that's what these two come together to give us. And then I can go 10x is equal to 6y plus 10 because of corresponding angles. Bring the y over, so I'm going to get 10x minus 6y equals 10. And then we'll combine those together. It looks like 42 would be the best thing, so I'm going to multiply this whole thing by 6 and this whole thing by 7, and that'll work out for you algebraically. We good? All right. If you would, make sure your name is on 3B only. If you're already stapled 3A to it, you're fine. Pass them off word. I don't need 3A, though, because I did the whole thing. Come see me then. Pretty good. Eugene. But he was like, he touched it and everything. It was ABC gum. All right. You guys and girls all ready? So I'm recording. All right. So, proving that lines are parallel, goal, develop and understanding ways to prove that lines are parallel. So, you know the statement, the converse, the inverse, and the contrapositive. So, a lot of the things that we've been doing, we could have said is if this, then that, and gone through and proved it all true. If you prove them all true, you create something called biconditional, which means you drop the if in the end and you put if and only if in the middle of it, right? So that's where these things are going to work. So we're going to be using the converse of the proofs from the other day. And that's going to allow us to prove that we have parallel lines versus saying we have two parallel lines. So what appears to be true about these two blue lines? It appears that they are parallel. Okay? It appears that they are parallel. Okay? Two lines with a transversal. The red line happens to be the transversal in this one. So that's what we're going to start proving. So we have a new postulate. If two lines are cut by transversal, so the corresponding angles are congruent, then the lines are parallel. So if we have corresponding angles congruent, we have corresponding angles congruent. So if I just drew a quick, we had this. This is a corresponding angle to that. Yes, there's three others that are corresponding. But if you have one pair of corresponding angles that are congruent to another pair of corresponding angles, that means that the lines, the two lines that are not the transversal, are parallel. Okay? Why is this one already out? I thought it was already. Okay. So what can we prove? Given angle 4 is congruent to angle 5. What kind of angles are those? Alternate interior, okay? So we know those. So our given, we could say that angle 4 is congruent to angle 5. That's a given. So we want to prove that G is parallel to H using the last one. So then I could go ahead and state that angle 1 is congruent to angle 4. Why? Vertical angles. And then I can say that, number 3, 1 is congruent to 5. Why? Transitive. Right? So then we can state what we just said here. Corresponding angles congruent, lines parallel. Corresponding angles congruent, 3 little dots. Could mean mi viva roca, or therefore in math, parallel. You're like, sweet, I'm going to start putting them here. My crazy life. Only got to work in gang territory for so long before you start realizing that certain tattoos mean something. Fortunately, you guys don't live there.
Soundtrack.
We proved. Oh, wait. Got to turn it on. I hope it's the song Jump Around.
And then you click it again.
Yay! Yay! I want to jump around. I got to put some better sound clips on here. So, if two lines are cut by a transversal so that their alternate interior angles are congruent, then the lines are said to be parallel. Oh. Alternate interior angles congruent, lines parallel. Okay. Yay, we just proved it.
Hooray.
Hooray. I think jump around would have been more fun.
What is jump around?
You
Who said that?
Like ice, baby.
We should have like
Yeah. The loudest possible death metal.
Oh my god.
Ready?
This isn't a dare. It's just
I'll take it.
I hope so.
All right. How about this one? Angle 1 and angle 3 are congruent. Given. Oops, wait. Okay. And then we know that angle 1. Nope, can't say that yet. We can state, though, that angle 2 is congruent to angle 3. Why is that? Vertical. Our buddy, vertical. So angle 1 is congruent to angle 2 because our old what? Transitive. So then we can easily state that angle A, or not angle, line A is parallel to line B because we can state that, oh, I forgot what angles we had. Corresponding angles congruent. Therefore, parallel. Therefore. No applause, just throw gum. Oh. Wait, I already got some. Huh. Oh, wait, what is all this? What? Oh man, what did we prove? If two lines are cut by transversal so that alternate exterior angles are congruent, then the lines are parallel. That's 3 and 3.5. Alternate exterior angles congruent. They're using the line, saying it for then. I like using therefore. Then parallel lines. How are we doing on this? We had to like a backside yet? Did you barf? I don't care what you say. When you see somebody barf, that's just downright funny. And how does a dog that weighs like 30 pounds weigh 10,000 pounds when you hear that low bass in the middle of the night? You go pick them up and they're like this. You guys know the bass sound I'm talking about? What's that? Dude, someone thumping? No, dog's barking. Oh. Sorry, I'm off the path. You guys know. All right, one more try. Angle 3 is supplementary to angle 5. Okay. So, things that we know. We can say, oh, come on, man. Angle 3 is supplementary to angle 5. Given. I might state something like this. Angle 3 plus angle 5 equals 180. What I do? Shh. Definition of supplementary, right? We do have, what is this? Oh. There we go. What happened?
Sawyer's crying.
What?
Sawyer's crying. I don't know.
It happens. Did somebody hurt him again?
Again? What did I miss yesterday?
Yeah. Eugene, are you shaking my hand again?
No, I
Oh my goodness.
opened the camera.
What do you got?
Okay, so I just told Sawyer
No.
my dog who had a condition, so he's like too old now, and so he's starting to like not be able to breathe. He's like hacking and coughing, and he makes that sound that you did for the bird, like
so sorry. I'm waiting.
in the middle of the night. And so I told Sawyer, and I don't know if he thought it was a joke or not, but he started laughing.
There's nothing wrong with laughing at your dog.
No, he said it's like. He said my dog's dying.
It's just the way Eugene said it, okay? It's just the way Eugene
It happens. It happens. All right. So, hey, what's two other angles that I could add together? You can give me 180. 5 and 6. Thank you.
Sorry.
I'd say that's linear pair. What do you think?
Yep.
LP?
Wait, could we also say definition of supplementary?
Supplementary would work. All right. Oh yeah. Giddy up. What if I were to say this? Too much talking back there. Sorry about dead dogs. Why? Transitive. Which means that I could then state that angle 3 is congruent to angle 5, or no, 6, excuse me. Why? What would I have done to this to get to there? Subtraction, good. Okay, and then angle 6 being that 3 and 6. 3 and 6, those are corresponding angles. So we can then say that A is parallel to B. Corresponding angles are congruent, therefore parallel. Perfect. Dude, this is so cool. Where am I at on this sheet? Are we down almost to the bottom of the second page or third page?
Down at the bottom.
Oh, sweet. All right, there, 3.6. If two lines are cut by transversal, so the consecutive interior angles are supplementary, then the lines are parallel. And I'm just parading the stuff in. Consecutive interior angles, supplementary, therefore parallel lines. We have plenty of time, I think. Guess we'll find out more of giant dogs. Ready? All right, given P is parallel to Q and Q is parallel to R, prove P is parallel to R. Oh, they have it there. Is that already there? Wait, where's this one? Oh, they have it there. Oh, we have to add stuff. Okay. 2, I would say, are correspond. Oh, it's already there. Parallel lines, corresponding angles. Where did this come from? Where did that come from? Is there something hidden here too? Oh, and then move that. Okay. I wish it was a scratch and sniff. But that's it. Parallel lines. Parallel lines, therefore corresponding angles are congruent. Angle 2 is congruent to angle 3 because parallel lines, therefore alternate interior angles congruent. Angle 1 is congruent to angle 3 because of the transitive property. P is parallel to R because alternate interior angles are parallel, therefore parallel. So let's see. I was just using that. You guessed it, another theorem. Okay. Almost there. We're more than halfway there. Can I move on?
There's like a little clip.
What? Oh, I think it's because I can move this up or down. Maybe we'll have that for later. Sorry, I didn't have to click. You guessed another theorem.
Whoa.
What?
If two lines are parallel to the same line, then they are parallel to each other. Oh. Transitive property of parallel lines. That's okay. If A is parallel to B and B is parallel to C, A is parallel to C. That's the transitive property. They're good gum. I haven't had this gum in a while. Thanks.
You can get it at the cafeteria.
My wife gives me a hard time because I like to chew gum a lot. And then she gets mad at me because I do one of those. And I know, but it entertains me. And it's only about me. Okay. Here we go. Now let's use the new theorem. Oh, good. New theorems. Okay, hang on. Help me out, everybody. Angle 1 is congruent to angle 2. Given. So that and that. Cool. All right. And then number 2, we can say that angle 3 is congruent to angle 4. Given. That and that. And then I can state that angle 2 is congruent to angle 3 because of Vertical angles. Good try though.
Thanks, dude.
So we can go. Do what? One is what? Well, I think we can make delete that one is congruent to angle. 1 is to 2. 2 is to 3. 3 to 4. So I can go 1 is I guess so 1 is congruent to 3. That's transitive.
No, that's already there.
What?
Oh, I wrote that wrong. You didn't hear me what I said. Okay.
Giddy up. And so then I get to use that. Wait. I could. Then 1 is congruent to what? 4. Why? Transitive. Right? I can use transitive twice? Uh-huh. Alright. Waiting. So 1 is congruent to 4. So this, and we're trying to prove that AB, we're trying to prove that this is parallel to this. So what kind of angle is this and this? And represent what kind? What kind? What? Who? Alternate what?
Interior.
Interior. All right. So then we can go ahead and state that AB is parallel to CD. And that is because alternate interior angles congruent. Therefore, we're then parallel. Yeah.
So, why would angle 1 be congruent to angle 4? I got angle 2 is congruent.
All right, hang on. So we want this 1 to 2, 3 to 4, nothing there. And then we know 2 and 3 because of vertical. So then we can go 1 to 3 for this one. And so then we have everything known here. So 1 is congruent to 3, which is here. 3 is here. So then we can state that now. Makes that leap.
Oh.
Yeah. Dude, I'm excited for you guys. Hey, who's coming to the dance on Saturday?
Will you go with me?
Yes. I'm one of the Excalibur club dudes, man. I like running, so that's our dance.
I'll be there.
So you better be there. All right, is A parallel to B? Explain why or why not. Okay, so I know that 5x is equal to 7x minus 20. So that's negative 2x is equal to negative 20. So x is equal to 10. Sweet. And then I might know that 5x is also equal to 40. So x is equal to 8. So I had corresponding angles here and here, right? And showed that x equals 8. And I had vertical angles here and showed x equals 10 here. So these are not parallel. Okay? They're not parallel because we were able to justify it a different way. Giddy up.
No.
All right. Homework is worksheet 3.3. Oh, we have a quiz.
Oh, no, thank you.
Oh, and a review tomorrow. Did I? Oh, cool. I love it when you're up on the board match. Everyone good?
Yeah.
Everybody happy? Anybody sad?